In today's video, we're going to be talking about some basic pulley problems. So the first pulley problem that we're going to start with is this. So let's say I have two masses m plus two masses capital M plus M and capital M minus M are both connected in a pulley. Are both connected to a pulley. Find acceleration and tension. Find acceleration and tension. So the first thing we have to do is we have to draw the diagram. So let's say we draw a diagram. So I'll give you a slight clue. So the clue is to draw the diagram. And now you have to identify which will go down and which will go up. Now to make life easier, I will call this M1, I will call this M2, I will call this M1, I will call this M2. So here let's say I have M1 plus M2. Here I have M1 minus M2. Now you tell me, the first thing I want you to imagine is which one will go down first. Which one will go down, which one will go up. Now this weight is obviously more, right? Because here we will get M1 plus M2 G. Here the weight, the force downwards will be M1 minus M2G. Now you tell me the addition of both weights or the subtraction of both weights, which one will be more? The addition obviously, right? So here that's why the acceleration will be downwards here and the acceleration will be upwards here. So now let us write both our equations. So we obviously know F is equal to ma, or we can say F net. So for this, for our first body here, it will become M1 plus M2G minus tension is equal to M1 plus M2A. M1 plus M2A. And then for this, because the acceleration is upward, right? Here tension will go upward. So that means tension is the first force. So that's why we'll take T minus M1 minus M2G is equal to M1. Can you see this side? M1 minus M2A. I'll write it again. I'll write this one again because you guys can't see it that well. So T minus M1 minus M2G is equal to M1 minus M2A. So if this seems like I'm going way too fast with this video, you should probably watch my last video because you'll be able to understand all of this much better if you don't know the concept or if you haven't watched my video. So now we add both of these equations, so that's why we will get tension cancelled here, right? So now what we will get here is M1 plus M2G minus whole M1 minus M2G is equal to M1 plus M2A plus M1 minus M2A. Now you tell me, I can take G common here and I can take A common here, right? I can take G common here, I can take A common here. G common here, A common here. So that's why if I take G common, I will get M1 plus M2. Now here minus will become minus M1 and here minus into minus will become plus. So minus M1 plus M2 G, which will be equal to M1 plus M2 plus M1 minus M2 whole common A. So I'll just move a little bit here. So now here I can take M1 and M1 will cancel here and M2 will stay here. So it will become 2M2G is equal to, now here in this case M2 will get cancelled. We will get 2M1A. Now you tell me 2 can get cancelled here. So we will get M2G by M1 is equal to acceleration. So our first answer for this question is, M2G by M1 is equal to acceleration. Now to find tension, what do we do? Now you tell me, all we have to do is just substitute acceleration's value in either of these two equations. Or what we can do is also use a formula, but honestly I don't like using the formula because by doing this we get more clarity and we understand doing the equation better. So let's say we use the formula instead. So what do we know tension as? So tension is equal to, 1 second. So we know F, so let's just substitute it in the first equation. first equation right here. So m1 plus m2g minus tension is equal to m1 plus m2 into m2g by m1. So now we can take tension here, we can bring this here. So A is equal to m2g by m1. I will write this up here. So here now we will substitute, we will bring this here and we will take tension to the RHS side. So we will get m1 plus m2g minus m1 plus m2 m into m2g by m1 is equal to tension. So now here what we can take whole m1 for the denominator, and m1 plus m2 plus m2g will get common, right? So obviously here we'll have to multiply m1 here, obviously. So what we get is, if we take m1 plus m2g common, we will get m1 minus m2, right? m1 minus m2 is equal to tension. So now m1 minus m2 we can take m1 square minus m2 square whole common g by m1 is your answer for tension. So tension is equal to this and acceleration is equal to m2g by m1. So this is the answer for this question. I hope you guys understood it. Let's solve one more question in this video. So obviously these videos are meant to be short for you to understand and to keep your concentration. Obviously, these two problems will not give you complete clarity on the whole question, but these are some of the important ones and some that will help you figure out stuff better. So now let's say I will draw the diagram. So I have one m mass here connected to another m mass here, connected to another m mass here, so on till n. So we have 1 mass, 2 mass, 3 mass, dot 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 till n mass connected to a pulley here, and there is one m dash here, which weight is downwards, m dash here, and tension. So now what you would be wondering is, on this side obviously tension will be applied in this direction, right? Because tension will always be away from the body. So now the question here is tension is equal to find. So we have to find tension. Tension is equal to how much and acceleration is equal to how much. So my question here is, can't we take this whole thing as nm? Now why do we take this whole thing as nm? Because there are n weights. Now obviously if you were to take 1 kg, 2 kg, 3 kg and n kg, then we would have to substitute a different formula. We would have to substitute the arithmetic formula. But here, because there are n weights, we can just take this whole weight as nm. This whole thing we can just take as nm, right? So instead of getting confused here, we will just take this weight as nm, redraw our diagram, have our m dash here with m dash g here, and have this connected like this. So now the problem here is tension will remain the same, here. So here acceleration will be downwards, acceleration will be in this direction. But here if you can see, for F net here there is no force in this direction. There is no force in this direction. So here tension will be equal to NMA. Tension will be equal to NMA. This is something that a lot of kids get confused. Oh no, there is no force here. What do I do? You just take tension is equal to NMA. Because there is zero force here, it will just become T minus 0 is equal to NMA, right? So T is equal to NMA. Very simple, very simple. But on this side, we still have M dash G, right? So we will get M dash G minus T is equal to M dash A. M dash A. So now T we can substitute, right? T we can substitute as NMA is equal to M dash A. So here we can take this common. So we will take M dash G and we will take A common. So we will get NM plus M dash whole A, and we will take this to the LHS side. So finally we will get M dash G by NM plus M dash is equal to acceleration. So you can see technically in the last video I did derive the equations. I did derive tension will be equal to this value, force will be equal to this value, but you can see I have not used that formula even once. Why have I not used that formula? Obviously it could make our life easier, but you see in this case that formula wouldn't even be applicable, because because this is on one side, this is on another side, right? So now after this, now that we have acceleration, right, let us find our tension. So we just substitute this in the NMA formula, right? So tension will be equal to Nm into m dash g by Nm plus m dash. Nm plus n dash. So finally we will get, one second, m small m sorry guys, I made a mistake here, is that we will not get our n. This is wrong. We will not get an m here, we will just get tension is equal to ma. Why? Now you might be asking me why. Because here this string is one string, right? This string is one string, but this string is another string. 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 So the tension here will be different. Tension here will be different. Tension here will be different. But we are not asked to find these tensions, right? Like 1, 2, 3. We don't want to find this tension. We just need to find this tension. But this string is just connected to the first stem, right? So tension here will just be equal to Ma. Yes, there are all these. Tension is still technically pulling it, but we just have to take T is equal to Ma. We do not need to worry about these. Trust me. So our final answer for tension, so our acceleration formula is still correct. So we will get m into m dash g by nm plus m dash plus n dash. nmg m dash g by nm plus m dash. Right. That's it. Yeah. So thank you guys for. We'll try and solve one more question. So this is the answer for this. I hope you guys understood. See, but then for the other formula for acceleration, because we still technically substituted tension is equal to n, we will get that because we still have to consider the n acceleration there. That's why we end up getting the n. All right. So finally, I want to take our last formula, and in this we'll be learning about, so let's say, so finally this is a very simple problem to end our session. So let's say we have a weight, we have two weights here, we have m here, we have 2m here. So I'm changing the question a bit. So now I want to find acceleration is equal to how much, tension is equal to how much. So here obviously tension will be upwards, but now you tell me where acceleration will be. So I will give you guys 2 seconds to try and solve this question. So acceleration here will be downwards for 2mg, acceleration will be upwards for this. Obviously, because this weight is less than this, obviously m is less than 2m, right? I mean, that's common sense. Like if this is 5, this is 10. So actually the question in our case is, this is 5 kg, this is 10 kg. But I've changed it a bit to generalize it. Because once you generalize it, then you get a better idea. So that's why we will get 2mg minus t is equal to 2ma, and then we will get t minus mg is equal to ma. So now we add both of them, tension will get cancelled, we'll get 3mg is equal to 3ma. Sorry, we will get mg is equal to 3ma. So m will get cancelled, g by 3 is equal to acceleration. So we've gotten our acceleration g by 3. So you see, even if we had 5 and 10, right, we would still get g by 3. And our tension would be equal to how much? Let's just substitute that in this equation. So we get 2m common, we'll get g minus a is equal to tension. So I've taken this and I've done it. So then we will finally get 2m g minus g by 3 will become 2g by 3 is equal to t. So our acceleration is equal to g by 3 and our tension is equal to 4mg by 3. So technically if I were to substitute m is equal to 5, right, we would still get g by 3, sorry, not g by 4, g by 3, and here we would get 16 g by 3. If the m was equal to 5, so then 2m would be equal to 10. That was our actual question in the book. So I hope you guys enjoyed this video. I hope you guys learned something new. So we did do some important questions in today's video, and in the next video we will be talking about pseudo force. Thank you guys for watching this video, and I hope I see you guys in the next one. Thank you.